Okay, so we can go and get started. Good afternoon, welcome. My name is Joe Zambrino. For the next 15 weeks or thereabouts, I'll be your guide through the wonderful world of problem-solving methods and tools for electrical engineering. I'm very glad you're all here. It's very nice to get a chance to meet you all. We will start this class off in, I guess, the most boring, traditional way possible by looking at the catalog description. It's always important to know what class you're in and why. If you're actually in the wrong classroom, this is the time you can quietly sneak out and no one will notice if you're not in the right class. This is W285, and that's the catalog description. And it's got some pretty, catalog-looking registrar-type words in there. So it's integration of field-specific computational tools for practically solving electrical engineering problems. That is the crux of this course. Another way to think about this course is how to use computers and how to program computers to be able to learn how to start to solve EE problems. And I kind of get to that to some extent with that second set of bullet points there. Why does this course exist? It's part of your programming pathway, and it's specifically for EE students. This is your programming pathway as an alternative to taking what I would call the more traditional computer science sequence, your Java 1 and your Java 2, or your Java 1 and your data structures course. Instead of doing that or taking those courses, you still have the need to learn how to program. Certainly, we have this course that is there for you. And that's my broader goal, to prepare you for those follow-on courses. Certainly CPRE 288, I feel part of my responsibility is to prepare you for that, as well as signal processing courses that also make use of programming concepts. Just more generally speaking, to kind of broaden your programming engineering knowledge skills and hopefully ultimately preparing you for a career where you're either going to be a programmer or if not, you're certainly going to be working with programmers. So that is the point of this course. I mentioned programming and computers several times. I think we need to make sure we're all kind of on the same page, although it's not necessarily a quick answer as to what a computer is. But when I refer to computer programming, and you'll be doing a lot of that this semester, it's just the process of writing, testing, debugging, and potentially maintaining the source code for computer programs. So your source code, these are the actual text documents that you're creating in the programming language that we are picking. And the programming language itself is defined by a unique syntax. Those are the rules for what is valid text for that programming language, as well as, and this is sometimes more trickier, the semantics of that language. When I use this particular syntax, when I use this keyword, when I use this kind of structure of syntax in my code, what does that given text ultimately mean to the computer? And that source code that you are entering and debugging and changing over time, it gets translated by some tool, and we'll talk about the compiler, but some tool directly to a format that's directly understandable by the CPU itself. So when I say this is a course on computer programming for EEs, I mean that's kind of what I mean by it. So we'll be having a programming language with a defined syntax. We'll have to really understand the semantics of that, and we'll be using tools to automate the generation from that syntax that's sort of human readable, human writable, to a format that the computer itself, the underlying computer itself understands. But we may have to back up potentially a little bit more, even more than that, getting slightly ahead of ourselves, arguably. So I say that's what computer programming is, and I use the word computer in every single one of those sentences. Can I get a definition from anyone? And by the way, I would really prefer, if this is more interactive, it doesn't have to be today, but in the steady state, I don't have 15 weeks of content of me talking. I mean, I can do it, but you'll get bored, I'll get bored, we'll all get bored. I want to hear from you. It's kind of a very traditional classroom. I can't walk around very easily, but I would love, whenever you have thoughts, questions, raise your hand, speak up, interrupt, it's totally fine. So that's the first kind of slightly philosophical question is, what is a computer? Any thoughts on that? Sure, back row.
It's a system that contains both hardware and software to essentially use it to solve problems.
I like the word solving problems. So hardware and software are that's a good way to describe what it's containing of. It consists of. It can be kind of hard to define a computer without using the word compute, and you managed to do so, and I appreciate that. So when we think of computers, it oftentimes has to do with solving problems, and that usually consists of two major things, and we'll be learning those as kind of separate topics, and all of the programs you're writing will be combining these two kind of separate topics. One is sort of calculation, doing math, and even if you don't think of yourself as mathematically inclined, and you don't think of programming as a math kind of course, it really is all applied math at the end of the day. In part because a lot of the examples we use are about mathematical examples because they're easy to test and easy to write. But secondly, because it's all just applied math. We are instructing the computer via the source code we're entering what math it needs to do. That's what makes it a calculator. So calculation is part of that solving problems. And the second part is decision making. So based on some math that we're having the computer calculate for us, we also write in our programs some sort of structures that allow it to make some decisions. You may have, if you've done some very structured programming, heard of like if-else kind of construct where we're splitting our path of our control flow through the code. And there's much more advanced kind of constructs than just a simple if statement that we'll be learning, but ultimately it all kind of breaks down to that. We do some math. Based on the result of some math that we've done, we do X or we do Y. We go left or we go right. We take a particular branching path. And that sounds maybe kind of straightforward. You know, the devil's in the details. It's in understanding the syntax of how to do that correctly in a way the compiler can understand. And it's also an understanding the semantics of the programming language that we'll be using and going with this semester. Okay, so that's a good description of what features, characteristics, qualities a computer should have. So calculation, computation, problem solving. Hardware and software is a very nice way of thinking about it. You know, in my line of research, we build a lot of sort of application-specific processors. So a processor that doesn't do a lot of things relatively well, but just does one thing extremely well. And in those cases, we tend to have very little software. It's almost entirely hardware in the designs that we build. Would we consider cognizant animals computers? Or are we computers? Can humans be thought of as computers? Sort of is a valid answer. What separates us from computers? And we can go deep into AI and things like that. Sure. We don't have to, though. Could be, absolutely. So consciousness, I guess awareness of self, and I'm not a philosophy professor, but something along those lines, it makes a lot of sense. The kind of relationship is fundamentally different, right? It's human telling the computer what to do. But in some sense, we oftentimes have our own sort of human program that we run. Sometimes we recognize it as such. Perhaps when we're doing arithmetic or other mathematical exercises, we're running our own human program. Other times it's obviously, a bit more subtle than that. So the human program, if the question I ask you as a human computer, human program, to figure out what is the date of 1 week from today, well, perhaps we just know it. Today's the 22nd, so 1 week from today is the 29th, right? Okay, so we can do it without really thinking about it. But if we had to kind of break it down, it's, well, first off, to answer any question, to solve any problem, as you mentioned, we kind of parse language. So there's some pretty advanced language analysis going on. Can you interpret a sentence that your instructor wrote? It's like answering a quiz, right? And figure out what is actually meant by it. There's ambiguity, there's bad grammar potentially, and understanding what the actual question is answering, what format the answer needs to be in. Then there's arithmetic potentially as well. There's the actual calculation that needs to happen. So what is the date 1 week from today? Well, even actually before we do the computation, what do we have to do? We have to figure out what today's day is. That would be the closest analogy to that would be like loading some value from memory. I won't get philosophical all semester long. It'll be today only. We'll be fine. But what is today's date, right? We have to grab that result, effectively like from our computer's memory. If I don't know what today's date is, I can't figure out what the date is 1 week from today, right? So we're loading some value, and we'll learn and see how to load from memory. Then I have to figure out, what math I have to do. So I have to add 7 days to that. That's 22 plus 7 to get 29. And I also potentially have to do some sort of decision making, as I mentioned, as the other component of what makes something a computer based on the result. 22 plus 7 is 29. Life's not so bad. If today was the 23rd, let's say if today was the 24th. Well, that's 24 plus 7 is 31. Are there 31 days in August? Okay, now I have to go back to the nursery school rhymes or look it up on a calendar to remember, are there in fact 31 days in August? I don't know, but if I have to know, I can look it up. But so there is some decision being made on that. Grab result from memory, do arithmetic on it, make some decision, relatively simple one, but making some decision based on the result, and potentially like storing the result or outputting the result. Okay. All of our programs that we write all semester long, and they're going to start relatively simple, and they are going to crank up in fun and difficulty, and for me those two things are the same over the semester. They all are going to be kind of like that. First off, there's a challenge of understanding the question, right? Understanding what is actually being asked for. As you become more adept at software development, as programmers, as potentially, software engineering side of whatever academic or, industry roles you may have, that is sometimes the hardest part. Figuring out what needs to be done is oftentimes harder than actually doing it once you've figured out what needs to be done. But then once you have figured out what needs to be done, your programs are always going to have that format. Okay, they're going to be doing more than calculating what the date is 1 week from today. But it's always going to be, what things do I need to store? And we'll learn as our first major module this semester about variables and memory. And it's a little low level, but I think you'll learn a lot through that. What things do we need to store and how do we store them? We need to figure out how we grab things from that memory and do arithmetic on them. That'll be basically the second module we'll be learning this semester. In the C programming language, that's conceptually not so hard, but you'll make mistakes, and learning how to debug that is probably the important learning lesson there. And then what do we do with the result? What kind of decisions do we make with the result? What kind of yes-no questions does the program need to ask and then answer to get our final result? Every one of your programs is going to have that kind of structure to it. And the problem solving, which is a critical component of this course, is going from maybe one sentence English language description to those kind of answers. And I'll tell you, oftentimes, write it out on paper. Students never do it, but I always suggest it. Don't start by coding, start by thinking about the problem. Because if you can think logically about the problem and think about what needs to be in memory, what math needs to be done, what decisions it needs to make, the syntax, you have to learn it. Certainly if you don't know it, it'll take some time to learn it, but it's not the hard part. It really isn't. And you'll get just better and better at it as you get practice. So that's the human program. It's not so different from the computer program. Now this one's a little trickier, right? Okay, what does this Rorschach blob look like to you? That one's a little trickier, right? Any suggestions? There's no wrong answers, right? Although if you go to a psychiatrist and you give the wrong answer, you might get in trouble. Okay, just say a butterfly. Okay, back row, sure. I like it. 2 waiters serving something at a restaurant. There, the human program is a lot harder to figure out. What thought process allowed you to interpret something visually and come up with some meaning associated with it. Computers are also getting better and better at that, and we have ways of describing that thought process. If you want to learn more about machine learning and convolutional neural networks and things of that nature, they don't do that well on Rorschach blobs, but on others they can tell you the pictures of a cat or of a dog, or it can do all sorts of crazy things for generating artwork as well. It's starting to become closer there as well. Even though for this one, writing out what that would be in English in terms of how my brain is determining that, maybe we'd be able to. I see 2 kind of symmetrical blobs, and it looks like it's someone leaning over. I follow you there when you say 2 waiters there. There's no right answer, obviously, for that. Maybe it's 2 people trying to lift something heavy. I could also see that there. There's no right or wrong answer to that. But being able to describe what the computer is doing in the equivalent analysis, that's a much harder thing there. Humans probably still have the leg up on computers in terms of being able to do that kind of abstraction. And one thing you will get to learn this semester is, and not just this semester, over your several years here at Iowa State, is kind of understanding the programming layers of abstraction. At the end of the day, your CPU, and we won't learn a lot of architecture, but the brains, the main processing component, the central processing unit of your computer, really only understands ones and zeros at the end of the day. Maybe you're aware of that, but it's a binary format that the computer itself would understand, and it has instructions entirely in that format. And the various pieces of software that we have along the way, we can describe those layers here, are just allow us a way as humans to encode something that doesn't take as much effort on our end to encode something that eventually gets translated down to those ones and zeros at the end of the day. One takeaway from a diagram like this and a way of framing it like this, and I always want you to think about that, is computers are not magic. And even when they appear to be acting in really bizarre ways, there's almost always a logical reason for why you're getting the result that you are getting. Very rarely is there a hardware bug. It does happen, but for the kind of things we're doing, it's almost certainly not a hardware bug. That process is being followed, and at some step along the way, we're getting a result where a 1 is a 0 and a 0 should have been a 1, and it's not, the computer is doing not what we would have originally intended for it to do. But we have those various layers of abstraction, And depending on how effective we want to be in terms of lines of code we have to write versus how much low-level control we want over what the computer is doing, we can be at different layers of abstraction. This is MATLAB up here, so that's a pretty high-level example of like sort of interpreted software code. We are writing something that kind of looks like a more traditional empirical software that we're writing, but it's actually interpreted. Line by line, there's a separate piece of software that's looking at each line and converting that. We'll be mostly in sort of native source code. This would be C code that we have here, but there's quite a bit happening under the hood of that as well. So the compiler is taking that. It's actually compiling down to sort of this assembly level of instructions. There's even a couple more, depending on your microprocessor layers below that, till eventually we get to our ones and zeros of our machine code. And if you understand that that process is happening, we can stay at that high level of abstraction quite often and only dive deeper when we need to. Either if we have to really debug something that just isn't evident at the source level, or if we need some really low level control of some underlying machine. In this course, we can stay in source code, the majority of this course. When you take some follow-on courses like CPRE 288, which is about controlling embedded systems, using software to control some other piece of hardware, we oftentimes have to dive here and understand why exactly is the computer doing exactly what it's doing? What happened in that translation step along the way? So why this course specifically? My personal philosophy is that programming is just critical for electrical engineers. So it wasn't that many years ago that the doubles would just take sort of a Java 1 course and be able to, if they chose, graduate without knowing how to program. That's not the case. Every single person in here, you will learn to program, and I can't make you love it at the end of the semester. I can't control what you love or don't love, but you'll learn to respect it, and I think you'll feel pretty competent in it by the end of this semester. That's my goal. I think the course is set up that you will do so. So even if you're positive that, I'm going to work in power systems and I'm never going to have to touch a piece of software in my life, I think the takeaways from this course will help you in your development as an engineer. All those examples and reasons are valid, and I think they're equally valid. Coding is a very clear abstraction of the engineering problem-solving process. If you're given a problem and you dive in and start typing, you're not following the problem-solving process. But to solve some of these more advanced programs properly, you have to really break it down. You have to think about big picture, what am I trying to solve? What are the intermediate steps along the way? How do I test? How do I know that it's actually working? Learning through failure is a critical kind of learning outcome of this class over and over again. Programming will humble you, I think in a good way. My goal is for you not to be terribly frustrated this semester specifically. If you're writing code and you have a bug and it's been, for any one individual bug, I have to be careful with how I frame this. If it's been 30 minutes and you've really been working hard on that bug and you just can't sort it out, that's when you can post on Discord. And maybe a classmate will figure it out, maybe the TA will be able to figure it out, maybe I'll take a look and figure it out. The goal of this course is not to frustrate you for hours on end, but learning through that failure. Hey, it didn't work until I made this change. I had to learn through that process. And just strengthening your debugging skills, software will really humble you in that sense. And that kind of problem-solving, critical thinking process is important no matter what you wind up specializing in as an engineer. In some sense, it's easier in programming than in some other disciplines. If we assume our hardware is valid, debugging software has a relatively straightforward set of tools we can apply. Debugging high-speed circuits is a lot harder, but some of the things you'll learn in this course, you can apply to debugging high-speed circuits. And then finally, learning how to code properly will help you become more logical, precise, and resourceful. Maybe you're already very logical, precise, and resourceful, but solving some of these programs, certainly by the end of this semester, you'll really have to be logical. You have to think. You can't just do, you will definitely have to think. You'll have to be precise, within reason. The compiler can paper over some issues in what you write, but it can't deal with ambiguity very well. And then resourceful is a critical aspect of just being a student. So many of you raise your hands that this is your first semester here. The successful students at Iowa State in our department, at least those with higher GPAs will say, are not any smarter than students with lower GPAs. They are sometimes harder working, but not necessarily so. But they're definitely more resourceful. They are willing to reach out for help. They're willing to look for other resources. They're willing to collaborate with others. My goal for you is not to suffer in silence for even 1 minute this semester. This is supposed to be a kind of fun course. It's as fun as we decide to make it, as fun as we make this classroom environment. But being resourceful is part of that. Being willing to reach out for help, being able to look up resources, interpret those resources, and apply it towards your programs. You're going to learn that this semester. So I mentioned C programming, and that's what we'll be using primarily in this course. Developed at Bell Labs in 1972. In terms of its common use cases today, mostly for so-called system software, so compilers and operating systems. Also for general purpose applications, like user applications, but less and less so over time. It's about 50 years old. It's quite old. It's older than me. So why am I making you use it? I have reasons. Primarily by design, it abstracts very little from the underlying architecture. To be an effective C programmer, you have to also understand systems. So that's the benefit. That's also the downside of C. So to get proficient at C takes a little bit more effort than becoming proficient at Java. For other languages, I can't necessarily say exactly what the rank order is of proficiency scale, but for that much, that's pretty true. So it's a little bit harder, but it does really force you to understand how the underlying computer works to some degree. And as a double E, I think that's fair game, that you understand how computers work, certainly by the time you graduate. The programming skill set is very upwardly mobile. That's very much the case that, you learn C. Traditional C++ will be very straightforward to pick up. Modern C++ is still pretty messy, but picking up Java, picking up C#, you'll have no problem with it. If you have to go off on an internship and your code will be in C#, you'll need the manual, you'll need the book on C#, you can't wing it, but you'll be fine. Everything that's in that book will be different than how it's done in C, but you'll be able to figure it out relatively straightforward. And the really high-level languages that are kind of solving some of the problems for you, like your MATLAB or your Python or Go, those will really astound you in terms of once you've learned C, how effective and how quickly effective you can be in those languages. They'll astound you in a good way that, hey, this thing that was 40 lines of code in C is just one line of code in Go. And so we start at the low level, and you'll get a chance, if you choose to go down more of a software path, to pick up those other languages and frameworks and be very effective as a programmer. And finally, the point there is, ultimately it's the fundamentals are all that matter. What is quote-unquote hot in software development changes on an annual basis and will certainly change by the time you graduate. So we start with an old, difficult language, and you're going to get pretty good at it. And when it comes time to learn something else, you're going to get pretty good at that much quicker than if you had started with only Python. You would probably struggle a lot more with C than going the other way around. So any questions about that so far? Okay. We also do a lot in this class, and certainly in the fall semester version of this class, with understanding the operating systems interface. We're going to be using Linux quite a bit this semester, but the environment's given to you. You don't have to do any messing with it yourself. So you'll learn how powerful the operating systems interface can be in terms of what problems you can solve with really not having to write any code at all. The modern term for that is kind of no-code solutions, but it's it's also a solution that's 50 plus years old now, using the built-in utilities of your operating system to solve problems. And you'll see that starting even this week in the lab. There'll be a few kind of get started with C programming examples, and one example that involves using the operating systems interface to solve a problem that's not so different than this one. So imagine you have all of these files on your computer, and every time the word Joseph is in the file, you'd like to replace it with Joe, but only if it's Zambrino. So I go by Joe, you can just call me Joe, Professor Zambrino. Sensei is fine as well, but you want to replace only those in your files for which that is the case. Every Joseph, switch to a Joe, but only if it's got Zambrino in the same line. You could do that in C. It's pretty painful. You write a directory traversal script and develop a program that searches line by line for Joseph, blah, blah, blah. You start thinking, but you can solve the problem. Certainly by the end of the semester, you can solve that problem in C. I hate to say exactly how many lines of code, because lines of code isn't necessarily a good metric for complexity. If I were to write that, probably, and I want to be reasonably robust, 100 lines of code. Not terrible, not wonderful either. The complexity of debugging grows pretty exponentially with the length of the program. There's actually a command, and figuring out what that command is part of the challenge, but in your built-in Linux or Linux-compatible system, there's already a command that can find every file. And for every file it finds, it can execute the stream editor command that checks every time there's a Zambrino line, search for Joseph and replace it with Joe. Done. And that's one command, and it's done without any code whatsoever. I want you to learn a little bit of that this semester, kind of in addition, but as a complementary thing to learn to just C programming and C programming 101, which otherwise the course basically is. That's a lot of reading documentation, Now that you know that command, it's done. You don't have to worry about it ever again. But knowing that there's a find command and how it works, knowing there's a sed command and the syntax for that is a little nasty. If you get to learn enough of that this semester, you'll just be so much more powerful with computers, and it'll pay just dividends throughout your time here at Iowa State and beyond. I have no doubt that you'll learn a lot through that process. So quick survey. How are we doing for time? Who here already knows how to program? Raise your hand. A couple of you, and it's okay. Yeah, no, and this kind of hand raise, so, you know, that I understand that that's totally valid. Who here does not know how to program? Awesome. I appreciate you being honest and willing to, you know, mention that. I like to bring in an introductory course kind of a quad chart like this, where on one axis on the x-axis here is kind of your self-perception of your own expertise from low to high there. How do you feel about your own, you know, ability to program? And your y-axis is your actual expertise. I guess as evaluated by someone else, by me or a TA, just by life experience, your actual expertise. And of course, if you fall into this quadrant, where you're actually very good at programming, and you know you're very good at programming, you'll be just fine in this course, obviously. I think there'll still be some challenge for you, so I think you'll still learn some things, but you'll do just fine, because you've already learned it. You know, you're here to get your degree, and you'll do just fine. So I'm happy for you, you're in that category. If you're in this category, well, that's probably not that likely. Like, you suffer from low self-confidence, I guess. You know, you think you don't know how to program, but you actually do. That seems unlikely, but sometimes you have people who don't believe in themselves and they actually know exactly what they're doing. That's fine. You'll be pleasantly surprised at how you're able to do all the assignments this semester. Likewise, those of you, and it seems like it may be a lot of you, you know, fall into that lower left category. You don't think you know that much, and you actually don't know that much. This class is for you. This is why this class exists. The default assumption is you fit into this category, and the class and how kind of the learning kind of scaffolds its way up through the semester, it's intended for you. You are in the right room. You're in the right place. The only kind of category, and it doesn't sound like we have any of them this semester, which is wonderful, are kind of those who would sort of fall into this. It's not a red X. You can still really succeed. Is when you have a little knowledge, but maybe you think it's a little more than that. You know, you took a programming course and you thought you learned a lot. I want you to go into this class with a little bit of humility in terms of, you know, you're here at Iowa State, you're here to learn. Assume until I prove otherwise that I know what I'm doing as an instructor. I feel like I know what I'm doing as an instructor in a course like this, and put a good faith effort in, because this is the only category of student who I think, you know, historically isn't happy with the results, maybe their grade, the end result of the class, where you think you know a lot, so you kind of half effort it throughout, and then you struggle a little bit because of that. So try to avoid falling into that trap. It doesn't seem like we have any based on that kind of informal survey there. C will humble you, you know, if you don't treat it with respect. I'll just say that, and you will find that this semester. Again, with the resources I will provide to help you at every step along the way here. So let's talk a little bit of syllabus issues. We'll get to the critical stuff, and if we don't finish it all, we'll talk about it more on Wednesday. We have 12 learning modules, or 12 main topics that we're covering this semester. All this stuff is on Canvas, man. You don't need to take pictures of anything. Yeah, it's all there. You got all the slides and everything. What I'm trying to structure it as, and we'll see how it goes, is Monday's kind of conceptual Monday. Hands-on practice on Monday, but so conceptual review on Monday. We'll have weekly quizzes on Wednesday. They're primarily attendance quizzes, so you show up, you take the quiz. If you get one wrong, you can go back and like change your answer and get full credit. So I expect, you know, everyone to get 100% on those quizzes. If you take the quiz and you got every question wrong, you know, that's a sign you maybe have to kind of like go back and look at the topic a little bit more. Maybe you didn't know it that well, but that's our Wednesday. So it'll be Quiz Wednesday, including this quiz. And then Friday, I'm hoping we'll be done with any slides, and we can actually sit and we can just do some live coding together. I think you can hopefully learn a lot through just seeing the practice and collaborating together on the practice of coding. So there's 12 topics. It's split over 15 weeks. Not quite one topic a week, but the steady state will kind of work out to be that way. Each topic's going to have a reading assignment on our kind of online textbook platform, as well as a coding practice assignment on using that Replit platform. Those links are all on Canvas. They're on these slides. They're on the main Canvas page. For the reading assignment, there will be the first reading assignment is on variables. So understanding variables in C, and you you kind of click a lot of things, there's a lot of mini questions throughout, and then for the coding practice, it'll just be submit some program based on that topic you learned. So it's not a very precise prompt, it's just get some practice outside of the lab environment without your lab partner, without a TA over your shoulder, of writing some program related to this particular learning module topic. And I think I say write a couple sentences about what you did. So that's the coding practice assignments. And then separate from that, we then have our weekly lab. So it'll be pair programming. I think we have an even number of students in both lab sections, so teams of 2 in your labs. Also using the Replit platform, but with very specific programming assignments. And basically for each one, there's 5 programs you're writing, 5 replets, 5 REPLs that you'll be doing for each individual lab with a partner. So the first thing we'll be doing this week in lab, and come to lab tomorrow if you're in section 1, or Thursday if you're in section 2, is we'll partner you up. If the partnership's not going well, we can always change things midway through the semester. Partnering you up, making sure everyone has access to Replit, making sure everyone's on the Discord, and having you just start to work collaboratively on those 5 programs. For this week, I think you'll get all 5 done in the 2 hours. Won't always be the case. Some of them will span multiple weeks. Some of them will have like 4, or let's say 3 easy ones, 1 medium, and 1 kind of hard one. And you may spend some time outside of the lab to work on those. So some small examples followed by some more sort of open-ended coding projects that we will have here. Questions about that structure? There's a lot going on. Sure.
Will there be lab reports?
In a very minimal sense, and you can probably, until you're in a team, you won't be able to see the first assignment in Canvas because they're assigned to teams. Let me just bring it up. Why am I trying to just talk about it? So I do have it open. So this is our Replit page. So Replit is a third-party company that does just programming, hosting. I really like them. They sometimes tweak their software like in the middle of the night for no reason, and then things break, and we'll get past those problems when they happen. But it's really cool, as you will see, for doing programming. Only myself and the TA are in there right now, and the labs are already posted. I've only published some of them, but there are actually all posted in there. And you'll see for lab 1, there are 5 programs. I'm getting to your question, it'll take a minute. There are 5 programs. As a student, there'll be a button to like start program, and you'll be able to actually access it. Just to give an example, although I don't want to modify it because it'll actually modify it for everybody, here's the second mini programming assignment for this week, Tuesday and Thursday. We haven't learned any C programming yet, so I understand the expectations are pretty minimal in terms of what I would expect you to be able to accomplish. This code has a syntax error. It's got a couple of them. Can you figure it out just by kind of looking at other examples and playing around with it? One thing you will learn about this environment, which is really nice, is so there's a way to view the files you have access to. There's your actual source editor here, and then there's your proper Linux console basically installed in a virtualized environment for you, all in this web-driven development. So you'll go in the lab, you'll work with your partner, you can kind of collaborate and kind of type at the same time as each other. When you have a problem, when something's not working, you can just send me the link. Send it to me on Discord and say, hey, this is the one I'm currently working on, I'm really stuck. Can you come take a look and see why I'm getting this bizarre compiler error? For me, compared to some of the other things I have to do for my job on a day-to-day basis, I enjoy doing that quite a bit. So never feel that you're bugging me or bothering me or asking too many questions. This platform makes it so nice. I can go from you have a problem and you post a question to helping with the solution in like 15 seconds. I can do it while driving if I want. I won't, but you could do it with just like half your brain. I'm very happy to help you with that stuff. But that's what these are individually going to look like. There'll be 5 of those for each of the lab. And if you want to preview, they're all there. And the complexity definitely does go up. So this week is, can we figure out one of the compiler errors here? I don't know if that's, can you see the syntax well enough even from the back row? I can make it a little bit larger if need be. Actually, probably the right way to do that would be in the settings. Let's try huge. It's a little bit better. Can we guess possibly what kind of bug we have here, even though you haven't done any C programming at all? Sure.
You're missing a quotation mark in 5.
Yeah, it'd be nice if it told you that. Let's see what it says. It actually does. And this will be one of our learning points that will take a little while to get used to. The editor itself, if it's a nice editor like this one is basically doing kind of compiling behind the scenes and trying to analyze your source code, it's going to try to give you a hint. Now, the hint will be in a hyper-technical kind of, phrasing. It's not going to be, hey, buddy, you're missing double quotes. It's going to be, like it says, missing, terminating, and it's kind of hard to see, but I think that's referring to, that's a double quote within single quotes. It's kind of hard to read. When I actually try to compile it with the so-called magic run button, it's complaining about something else first, and it is saying, the compiler's pretty smooth. Missing, terminating, double quote character. You have to learn how to interpret this, but it's literally saying, on line 5 in main.c, it's the only file we have open here, in column number 13, we are missing a double quote character, at the very end. So you'll go through this one, you'll fix the bugs. I don't actually want to fix all the bugs because, well, then it's kind of solved for you, but hey, okay, you got your free one, and then the code now runs and compiles. So it's also missing, as we'll see even on Wednesday, it's missing just include needs to have the hash or pound symbol in front of it to be able to include that file. Once you've gone through, you're going to go and submit each of these programs in the Replit platform. REPL is just an acronym. It stands for read, eval, print, loop. But for them, it's more of a marketing. It's an environment that allows you to quickly build and test programs. And that's all this is, with an educational kind of veneer on top of it. You would then go into the schedule. The schedule page is decent, and under lab, you'll see the submission for it. And it says specifically what I want you to do. So complete means to follow the README instructions. Demo means to either show your TA during lab or provide a direct link to the REPL here in Canvas. And submit means to submit the project in REPL, and briefly means 1 to 3 sentences. So for buggy print, it was 1 to 3 sentences. Briefly explain your problem-solving process. That is your lab report. And my goal, we have some relatively small amount of TA hours. I want the grading to be relatively straightforward. I don't want there to be any controversy about any grading all semester. There's 5 of these assignments. There's a rubric in Canvas associated with it, and I've told the TA, Brandon, okay, they wrote a few sentences, they hit submit and everything, click, 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 full score, on to the next one. So it's not an in-depth lab report, it's not paragraphs upon paragraphs that you're writing. 1 to 3 sentences about each of these projects, and there'll be 2 of you in a team. Last fall, some teams truly split it, like I'll do 2 and you do 3. I think the more effective teams kind of tried to work side by side, and maybe someone did 60% of the work for that program and the other person did 40%, but 2 is better than 1, I think, for programming. You'll learn a lot from your partner as well. Let's since I have it open here, let's briefly take a look. So this is the main Canvas page, and it looked like people had access to. Those are my office hours there, and the TA's office hours as well. So my office hours are today, so 1 o'clock today. You're welcome to come by. I don't think you have any technical issues as of yet, but you're welcome to come by and say hello and introduce yourself in person if you'd like to, one-on-one. That'd be fine. Anytime you need to meet with me outside of those office hours, you can ping me about that, and we'll see what we can do. It could be via Discord or something if I'm not in the office at that particular time. We have the syllabus, and as always, I do recommend you read through the syllabus. I don't think there's anything controversial in here, but it mentions how to access the Zybook. So for our textbook, I'll talk about that on a slide here as well. Policies are relatively fair and straightforward. I guess one aspect that is always important is kind of the integrity of scholarship and grades for a programming course. You'll be working with teams. So you and with your partner in a lab group, you share 100%. So you are one submission for Canvas. You don't individually submit it, you submit it as a group. I do want a collaborative atmosphere. If someone posts a question on Discord and I don't get to it because I'm driving or something, and you know the answer because you kind of thought about this problem, you can help them work towards understanding and get towards an answer. I want us to help each other. I want us to feel this is a collaborative atmosphere, not a competitive atmosphere. You just gotta watch out for kind of just copying other people's code. So in week 1, it won't be an issue. Maybe right around week 6, the programs start to get of sufficient complexity that it'll become pretty obvious if you've copied versus done it yourself. And all that paragraph says is don't do that. So ask for help. Come to office hours. Ask questions when you're stuck. Don't copy. I'll catch it. I'll feel bad. You'll feel bad. It's just bad. So don't do that. But so read that paragraph to get the formal description of that. So maybe I'm speaking out of both sides of my mouth there. I want us to be collaborative. I want us to help each other. but there's helping each other. Oh yeah, you're missing a semicolon there, you're missing a double quote there, that's why you're getting that error. That's helping each other. Or, when I had to solve this program, I already did it. I kind of thought about how I could use this for loop and then consider doing this. That's helping each other. Here's my file, you can just submit this. Change all the variable names and submit it as yourself. That's an integrity issue. So do the former and try not to do the latter, and I think we'll be okay. And the other thing you can look at is then our schedule, kind of as a sort of web page table here in Canvas. So all of the slides are available there under that Lect-01. There's just one slide per page and 4 slides per page version. There's going to be a link to our quiz, which will be on Wednesday. You can take that in class with us on Wednesday, and then a link to the submission for the labs, the reading assignments, and the coding practices. So there's a decent amount to keep track of, kind of as our steady state. So for each of our topics, and each week there'll be a quiz. You just have to show up, so please be here on Wednesday. Show up to your lab each week, so there'll be a lab associated with it. There'll be a reading assignment. That's in that Zybooks platform. You do have to log in and get access to that. So I have access, but I can't easily tell who has access until we get to a certain point in the semester. But your first reading assignment is that kind of introduction to C, and it's kind of okay. It's like a textbook. There are approximately 1 million different C programming textbooks, and when I had to kind of decide for this class, I looked at this version. I thought it was okay. None of them are amazing. None of them are necessarily terrible. This one seems okay. It's got a couple nice features. It lets me track how far you got in a chapter, or your student spent 30 minutes on this little question in this chapter 3. Maybe you should spend some more time on it. It's got a little bit of that analytic side of things. But if you have some other resource that you also prefer, that's also fine, But it's competent, and I think if you do go through and do the assignments in good faith, the reading you'll do pretty good with learning the introduction to C material we have in this course. So that is our steady state. So we have our lecture, our slides. Again, I'm not going to talk for 45 sessions this semester. At least I hope not. We have our quizzes on Wednesday. You have your labs. That's just right upstairs, Tuesdays and Thursdays, depending on your lab section. You have your reading assignments, and you have your coding practice assignments, where if we look at the coding practice assignments, that one is individual. But after completing the reading assignment, create a REPL on that Replit platform that demonstrates something that you've learned new in C. So provide a link to it and write a few sentences about what your program does. And again, that should be straightforward for the TA to grade. Just checks your REPL. Okay, it is using this new topic of for loops. Hits the full credit button. We all get to move on from there. Other questions about course organization, things of that nature? None? Okay. So I mentioned office hours. That's me. Mondays and Fridays, 1 to 2, and for whatever reason, whenever you need to meet. So we can use Discord for that as well. If it's a time I won't be in the office and you really still need help, we can use that audio channels there as well. I say TBD for the TA, but his name is Brandon. He's taken the course. He's a grad student. I feel like his role is not necessarily to know everything, necessarily. It wasn't that long ago he was an undergraduate student like you in this course. But to be available, to be someone who can bounce ideas off, to ask questions about, grading or anything else related to kind of syllabus items in the class. He will be there in the lab with you on Tuesdays and Thursdays. I will try to stop by on occasion. And he has his own separate office hours just down the hall here in the TLA. Come by and see him Wednesdays 2 to 4. So we're here to help. Communication is key. So don't suffer in silence this semester. Come to office hours. Last fall when I taught this course, there were some students who came to every single office hours, and they knew they needed the help, and I was willing to do it, and they did quite well in the course by the end of the semester. And then there was a couple others who just kind of struggled and didn't want to reach out for help and just said, I'll figure it out eventually. They still also survived, but could have done a lot better if they had gotten access to those resources. So Canvas is kind of our class web page. I'll post announcements there. All of the files you may need for slides and things like that are there. Your submission of stuff is on that Canvas, and that's where you'll see your grades. And then Discord for all kinds of class discussions, formal and informal, and sort of if we have any virtual office hours as well. So I would like you to join the Discord. Again, just the turnaround time of my being able to help you is going to be a lot faster on that versus shooting me an email or trying to use a Canvas message or something like that. So We have just the one TA, Brandon, he's fine. I also have my special, additional teaching assistants. Joey is now a freshman in high school. There's Tessa, and then there's Johnny. Johnny will help me with grading occasionally. So as you do your write-up, try to reach for a 9-year-old reading comprehension level in your submissions, and I think we'll be just fine. They're not actually going to help me with grading, but fine. So I mentioned this. We're using an online adaptation of a fairly typical introduction to how to program in C textbook. I'm not going to rant and rave and say it's the best textbook ever created or anything like that. I've grown to like it. I like what it provides for me as the instructor. There are many decent C programming books out there. On Canvas, I posted a few that have a couple different things going for them, different from the Zybooks. But the Zybooks one is our required textbook. So you have to go to that Zybooks website, you have to enter in that code and subscribe. I don't entirely know how the U bill works for that, but it gets automatically added to your university bill, and you do have to actually purchase it. It's worth 10% of your score completing those reading assignments. A couple students last fall just didn't do it and just took the 10% hit. You can do that if you choose to. I feel like you're hurting yourself. I think it's $57 or something like that. It's not wonderful, but it's relatively affordable compared to a paper and hardbound textbook. But you do have to actually purchase it, at least for this class. At least that's my expectation for you. Again, I think I mentioned, but that's our tentative kind of weekly layout. So Monday, Wednesday, Friday. Monday we cover concepts such as they are. Wednesday's our quiz and probably kind of hybrid concepts in practice. And I'd like to try to reserve Friday for kind of collaborative programming together. Not necessarily working on the lab assignments, because you have your own time to do that, and you can help from the TA and from others. But applied versions of what we've been trying to cover in class. Probably, I'll be driving the primary amount of programming. You can connect to the Replit that I'll be on and see what I'm typing, but you can also see it on the screen here. And kind of working together towards some solution that applies some of the concepts we've been learning. I think you can learn a lot that way. You can only learn so much just listening to me talk, for 50 minutes. So I think that'll be a good use of our Friday time. There's the office hours listed there, and hopefully you do know which lab section you are in. Who here is in lab section 1? Show of hands. There's more of you than that, and that's okay. Check that tonight. Go to lab tomorrow morning, 8, 10, something like that, a.m., and be there. I do expect lab attendance, every week for your lab for this class. And likewise, for those of you in the Thursday afternoon section, we'll see how that goes. And you'll get your partner. You'll get started on the first assignment. Hopefully, you'll get a feel for what this class is really about on that first day. Finally, the last thing I will mention in terms of today, just the syllabus items, just to get through it. Those are the main grade components. So we have our reading assignments. There's 12 topics, but I don't assign a reading for the 12th one. There is one, I just didn't want to assign a reading that late in the semester. So 11 reading assignments. Likewise, there's 11 coding practices you'll be doing. You have 8 kind of, call them individual labs. Some of them are 2 weeks, but most of them are just 1 week labs. And then there'll be one programming project you'll be working on that you'll get to propose what the project is. You get to actually design your own kind of grading rubric for the programming project. We have our quizzes. Most of them are going to be these kind of very short, just attendance quizzes. I have reserved 3 Wednesdays this semester for, I'm not going to call them a midterm because they're really not, but just like macro quizzes. And that is kind of a cumulative quiz of all the content we've covered up to that point and scored accordingly. And then I leave that sort of 5% class participation. If I know who you are at the end of the semester, you'll get your 5% for that. So that's easily obtained by coming to office hours or posting on Discord. And I know who you are, you participated in the class, that's good enough. Maybe unfair to the horribly introverted amongst you, but I'm horribly introverted, so we'll have to get through that together. I'll use the default ISU grading scheme, and we absolutely can hit a class 4.0. That's more up to you than it is up to me in some sense, but that's my goal. This class is created so that you can get an A in this class. I'm not trying to show how tough I am as a grader or anything like that. So I think we were like a 3.7 last fall semester, but students did have to work on it to get to that point. You can absolutely get an A, certainly if that's your goal. Certainly if it's your first semester here at Iowa State, this is your first double E class potentially then at Iowa State, Yeah, shoot for an A. You have plenty of additional classes to get bad grades in maybe down the line. Shoot for an A in this one. And I think I mentioned this as well, yeah. Encourage of collaboration, being resourceful, asking questions. Keep in mind kind of the academic integrity aspect. So you have a lab partner, and this will be our last slide here. Make sure both members of the lab team are contributing. Let me know, let the TA know if your lab partner is doing absolutely nothing. It happens, so I just need to be made aware of it, and we can maybe reassemble teams or do something about that. And just be careful about copy pasting solutions. I tend to write these programs in such a way for the assignments that it'll be kind of obvious if you copy paste either from other students or from other online sources. They're like traditional C programming problems, but with a little twist, and figuring out the twist is usually the hard part about it if there is any challenge associated with it. Let's leave things right here for today. Some of you, see you tomorrow morning. The rest of you, see you Wednesday for our quiz. Come see me in the office hours if you have any questions. Looking forward to it.